Now, today's session is how to use multiplication theorem. Now, you have two concepts called with replacement and without replacement. Okay. So, with replacement, this is WR. Now, next one, without replacement, WOR. Now, in these two cases, you will be using the multiplication theorem. Now, let me give you one example. A box contains 3 white and 4 red marbles. 2 marbles are drawn, one after the other. Find both are white in color under with replacement. So second one, both are white in color under without replacement. Okay, now I'll read it out. A box contains 3 white and 4 red marbles. 2 marbles are drawn, one after the other. Find the probability that both are white in color under with replacement. Now second one, both are white in color under without replacement. Now what does it mean with replacement? Now you see this box has 3 white and 4 red. Now what you have to do is you have to draw now 2 red marbles. So one after the other. First one you take out 1 marble. Then you see what is the color. Again you take out 1 more marble. So when you say with replacement means what you will do, there are 2 draws now. So you will have A is the first draw. Okay. Now B is the second draw. Are you able to understand? So in the first draw you take out 1 marble from the box. Now you see, you have to see that color has to be white in color. So after that you have to take 1 more marble again in the second draw. Now suppose with replacement means what you will do? You will take 1 white marble. Okay, you will see that. Again you put it back in the box. So what happens is, so when you are taking out 1 white marble in the first draw, after that you are putting back. That means you are replacing back. So then again you will take 1 from the second draw. So the number of the marbles for the second draw remains the same. Okay. Now to make it more specific, we can write it like this. So first case with replacement, right? So A is drawing a white marble. Okay. Marble in the first draw. Understood? Now I'll write it like this. See. So first part is with replacement. So let A be the event of drawing a white marble in the first draw. Fine. Now what is B? Again it should be that both of them should be same colors, white color. So white color in the second draw. Now here A and B. So first one 1 marble and second one 1 more marble. So it means probability of A intersection B. So that's why we will be using multiplication theorem. Okay. Now with replacement, it means you will take out 1 white marble. So it becomes probability of A. After that you see the color, you put it back, you replace that back. So what happens to the second draw? The number of marbles for the second draw remains the same. So therefore it becomes now independent. Okay. So you will be using the independent theorem whenever it is with replacement. So what is that one? White color. So out of how many? So 7 are there, right? So number of exhaustive, same type you will have to use now m by n. Okay. Now A is now what? White color out of 3. So 3C1 divided by 7C1. Okay. Now coming to the next one. So whatever white marble you have taken, you are putting back. So this remains the same. White color is the same. So 3C1. So 3 into 3 divided by 7 into 7. Okay, fine. So 9 divided by 49. So for the second draw there is no change. So it is independent. So you will be using the theorem for independent events. So understood? Now when it is without replacement, now what does it mean? It means, so you will take the first white one in the first draw. You will see that you will keep it outside. So you are not putting back. So what happens to the number of marbles for the second draw? It is decreasing. It will decrease by 1. So that means for the second draw the number has reduced. If that is the case, for the second draw now depends upon the first draw. So here you will be using now the dependent events. Okay. Now same type here under without replacement. Now the change will be like this. See. So A, B, same thing will be. First one, white one in the first draw. B, again white in the second draw. But you have taken one white marble in the first draw, you have kept it outside. So for the second one, the number will reduce. So therefore it becomes now probability of A intersection B equal to probability of A into probability of B given A. Because already one white marble is outside. So the number of white marbles for the second draw changes. So here it will become now. Same type. First part is same. So 3C1 by 7C1. But for the second one what happens is one white is already outside. Number of white marble for the second draw will reduce by 1. So where it was 7, now it has become now 1. So it has reduced. So it becomes 6. And here number of white marbles. So it was 3 previously. But first draw you have taken it outside. So number will again reduce. So it becomes now 2C1. Okay. So therefore this will be now 3 into 2 divided by 7 into 6. So this will be 6 divided by 42. Now this is how it will be. Okay. Now this will become now which one? For dependent events. So two things you have to remember. So when it is with replacement, you are using independent events theorem. Now when it is without replacement, you will have dependent events. Okay. Now same way you can have one more question also. Now instead of both O or white, I can have now. So first draw gives one white marble and second draw gives one red marble. So same thing you can have under with replacement and without replacement. Now accordingly you will have to change the color now. For the second one you will have to change the color. Okay. Now suppose I have to change now. So you have 3 white and let us assume 4 red. Now first draw should give you 1 white and the second draw should give you 1 red. So I have changed the colors of the marbles now. So under with replacement and without replacement. Now you see with replacement what did we use? Probability of A into probability of B. Okay. Out of 7. So 7C1. Now this is first draw is white. So 3C1. Okay. Now whatever you have taken, you have seen the marble, you have put it back. So this remains the same. But what should be the color? Second one should be red. So out of 4. So therefore 4C1. So 3 into 4 divided by 7 into 7. So 12 divided by 49. Okay. Now coming to the second part without replacement. So you take that color, whatever the marble, but you keep it outside. Don't put it back. So this will become now probability of A into probability of B given A. Okay, now this is actually our independent theorem. Okay, now this way I have to write. So small adjustment. Okay. Now first one, what is that one? White color. So same, this remains the same, 3C1 by 7C1. Okay. Now coming to the second draw. Now second draw, what has happened is already one white marble is outside. So this will reduce now. 7 will become now 6. Now what was the color? So white color, but for the second draw, what color we want? We want red color. So this will be the same, 4C1. Only this part will change. So therefore 3 into 4 divided by 7 into 6. So this is 12 divided by 42. Okay. I hope everything is clear. Thank you.